slightly different shades of blue just because, like, I mean, there are different amounts of water, ice, and stuff like that will slightly change the color of the planet. Okay. And I'm actually going to start controlling the tour now, if it'll let me. They give us Xbox controllers to control this stuff.
So except for Pluto, all other planets have similar, I mean, they are located on the surface, the same
like
surface?
Yeah, so yeah, here's another look at Pluto and how it has a really weird orbit. So I'm going to start zooming out now. I'll just say goodbye to our solar system. The sun just becomes kind of another point of light. Just keep in mind that the sun is just another star. So all of these stars you see are actually, they could have entirely other planetary systems. And these are all real stars in their real locations. You'll see that stars kind of have different, some of them are brighter than others, some of them are more white or red or blue than others. This is because stars, just like planets, come in all kinds of different compositions and sizes and everything. Sometimes stars are born in families called open clusters like this. Yeah.
What are those white lines?
The white, oh, you see like the faint white lines. That's just the room. It's not a real like thing at all. It's just the kind of the way the ceiling is set up. Okay, so what we're seeing now is the Milky Way, our home galaxy, coming into view.
So milky.
And that is our real location inside of our galaxy.
Huh?
So this is the Milky Way. It is a spiral barred galaxy, and it's called that because it has the spirals coming out of it. And you look at the middle, it actually has like this bar of brightness, and just the brighter spots are just areas with more stars. And the Milky Way has about, I believe, like 200 to 400 billion stars in it. It is about 100,000 light years across, which means that light takes 100,000 years to get from end to end. And in the middle of it is a supermassive black hole, which is not going to swallow us up, by the way. It's just kind of like what all the stars orbit. And all the different colors are nebulas, so you see there's like pinks and purples, and those are kind of areas where stars are being born out of the gas clouds.
So new stars are on the outer area?
Yeah. He said new stars are on the outer area. There's a lot more star birth in the outer areas than in the middle. In the middle you see kind of orangish colors. Those kind of denote older stars. So not a lot of actions going on there. Let me keep zooming out here. And I'll explain what those lines in the back are in a second. Okay, so at this scale, every single point of light is an entire galaxy. And these are all real galaxies in their real positions.
Where's the Andromeda galaxy?
Where's Andromeda? I actually don't know if this program has it. It might. I feel like I'm actually not sure where it is in here. It might be one of these. It's so hard to tell. It's so faint. The Andromeda galaxy, for those who don't know, is the nearest spiral galaxy to the Milky Way. So it's a lot like our own galaxy, and you can actually see it if you have clear enough sky at night.
Excuse me?
Yeah.
Can you like zoom into one of the other galaxies?
I can't like go into the same detail we went in the Milky Way, but after I zoom out all the way, I'll come back in and we can take a close look at some of the other galaxies.
Wow, so many galaxies.
How do you
Yeah, how do we know the position? Well, that's a great question. There's a lot of different methods. They can use what they call standard candles, which are kind of objects that astronomers, they know the exact brightness of it. So if it's always constant. So if it's an object that's far away, it'll be dimmer a certain amount. They can actually use that to predict mathematically where the object is. But there's a lot of crazy methods, but basically they use telescopes and interpret the amount of light they're receiving. And this like weird shape. Let's see, let's rotate it around.
Yeah.
Yeah, so it's kind of like these weird wedges that are cut out. That's not what it actually looks like in real life. This is actually just one of the surveys that we've taken of the sky. It's called the Sloan Digital Survey. And the reason why there's complete gaps is because there's actually dust in our own Milky Way galaxy that's blocking our telescope, so we just can't see over there. But this big bright area is an area where we can obviously see a lot.
Oh.
And so I'm going to zoom back through, take a look at different kinds of galaxies. So this one right here that you can see is another spiral galaxy. A lot of there's two main kinds of galaxies. There's spiral galaxies like our own in this one, and then there's elliptical galaxies, which are a lot less interesting looking. If I can focus, it's very difficult. Okay, so you'll see that some of them are just kind of orange blobs, and those are more ancient galaxies that possibly went through a collision that messed all their spiral arms up, and so they are just kind of these round clouds.
Galaxies in one galaxy.
Oh, what? Why? Wait, what was your question? Like, so, are you asking like why they're clustered together? Yeah, okay. So yeah, just like stars, galaxies form from collapsing gas clouds, and they have their own gravity, so they kind of attract each other, and they can stay in these families called galactic clusters. There's clusters and superclusters. We'll zoom in a bit of time.
Oh. So the size of all these galaxies, are they the farthest extent of our scope detection, or?
Yeah, that's a great question. So like how far are we looking at now? So from the center to the right side of this wedge, that's about 2 billion light years. To put that in perspective, the observable universe and the furthest objects we've seen are 13.7 billion light years away. So if this was a complete survey of the sky, the entire dome would be filled with galaxies right now.
Oh, so we just cannot look farther.
Yeah, well, in this specific survey, we didn't look farther, but we can actually, there are galaxies we discovered that are
Outside of the sphere.
Those galaxies don't even really exist right now.
Yeah.
Looking back in time.
Yeah, so every time you look at an object in the sky, you're actually looking at it back in time. So when you look at the stars in the night sky, some of them might be 1,000 light years away, which means that the light that came from them originated 1,000 years ago. So if that star disappeared, then it would take us 1,000 years to notice. Galaxies are the same way, but on a larger scale. These galaxies are billions of light years away. So what we see now is basically a baby picture of them.
Oh.
And
They might be already adult.
we're out of time, actually. So that concludes my tour of the solar system and the universe.